So these are the revision questions for the P4 revision. I've got a highlighter, I've got a calculator, because we're going to need to use both of those things. So components can be connected in electrical circuits in different ways. Draw one line from each circuit symbol to the name of the component it represents. So this circuit symbol is a lamp, and this circuit symbol is a fuse. This sometimes gets confused with a resistor because a rectangle is a resistor, but when it's got the line all the way through it, that's the symbol for a fuse. Complete the sentence. Choose an answer from the box. Electric current is the rate of flow of charge. Figure 1 shows a parallel circuit. Calculate the current measured by ammeter A2. So the rule for current in a parallel circuit is that the current in the branches adds up to being the current kind of before the split. So I need to find the difference between these two, and that's what it would be here. So 0.56 minus 0.43. So we can just do that on the calculator quickly. 0.13. So that current is 0.13 amps. The total current in the circuit stays at 0.56 amps. Calculate the total charge flow. Use the equation charge flow equals current times time. Okay, the confusion has come from it's chopped off a bit of my printer's chopped off a bit of the top of the question. It should say, and on your document it should say, the circuit is connected for 300 seconds. Use the equation charge flow equals current times time. So we're finding out the charge flow, which is Q. The current is 0.56. The time is 300 seconds. So we can do 0.56 times 300 is 168 coulombs. There. So the potential difference supplied by the battery is 4.5 volts. Calculate the total energy transferred in 300 seconds. Use the equation. Energy transferred equals charge flow times potential difference. Use your answer to part D. Well, we've just worked out that was 168 coulombs. So the charge flow, so energy, is equal to the charge flow, which is 168 coulombs, by the potential difference, which is 4.5. So I saw what was left over on my calculator, so I can do times 4.5, and that's 756 joules. You don't have to write your answer here. If it's written here, that's also acceptable, but if it makes you feel better about knowing that it's in the exact answer line, it's worth copying it into there. Figure 5 shows a series circuit. Resistor R2 breaks. What happens to the reading on the ammeter? It will decrease to 0. Okay, because if R2 breaks, then that means that there is a break in the circuit. There's only one loop in the circuit, so therefore the current will be 0. So now we have a parallel circuit. Resistor R3 breaks. What happens to the reading on the ammeter? And we've got two ammeters here, A1 and A2. So R3 is the one that breaks. So A1 is going to be no current flowing through here, so it decreases to 0. Okay, but A2 won't be 0. However, it will still decrease because the current drawn from the power pack or the battery will decrease. Figure 4 shows how the resistance of a component varies with temperature. So we've got a graph, we've got temperature in degrees Celsius along the x-axis and resistance in ohms on the y-axis. Probably going to come back to that in a minute. What is the name of the component? So we have LED, LDR, resistor, thermistor. So let's think about this. LED stands for light emitting diode, so it's definitely not an LED. LDR stands for light dependent resistor. Again, it's nothing to do with light. And it's not a resistor. So first of all, we can get this from it being a thermistor, which is a temperature-dependent resistor. And the pattern with a temperature-dependent resistor is that as the temperature increases, the resistance decreases. If it was a normal metal, it would be the other way around, that as the temperature increased, the resistance increases. But a thermistor is made of a special material called a semiconductor, which means that the pattern is the other way around. What is the resistance of the component at a temperature of 50 degrees Celsius? So we're going to go back to our graph, and we actually need a ruler this time. So we're going to find 50 degrees Celsius is here, draw up to our line, and then across. So 165 ohms. Okay. 165 ohms. They would accept between 160 and 165 for this particular question. Okay, question 2. Figure 1 shows a circuit diagram containing two identical lamps arranged in parallel. The reading on the ammeter is 186 milliamps. Okay, so that's 186 times 10 to the minus 3 amps, or 0.186 amps. Okay, so you need to be able to look out for things like this, and you need to be able to, so I always suggest read through the question and annotate as you go along. So we've got this diagram. Which statement about the current through the lamps is true? So the current through both lamp P and Q is 0.093 amps. The current through both lamp P and Q is 0.186 amps. The current through P and Q is 0.93. Current through P and Q is 1.86. So they're testing two things here. First of all, can you convert from something being given in milliamps to something being given in amps? And then second of all, do you know the rules for current in a parallel circuit? So the reading here is 0.186 amps. But when it gets to this point here, to this junction, it's going to, some's going to go down this branch and some is going to go down this branch. Now it tells us it's two identical lamps, so therefore it's going to split in half. So therefore you're going to have half the current, half of 0.186 going through P and half of 0.186 going through Q. So we can 0.186 divided by 2 is 0.093. So therefore it's 0.093. Okay, let's keep this in case we need that diagram. One of the lamps breaks and is not replaced. Which statement about the current in the other lamp is true? So the current through the lamp is 0.093 amps. Current through the lamp is 0.186 amps. Current through the lamp is 0.93 amps. The current through the lamp is 1.86 amps. Current through the lamp is still going to be 0.093 amps. Figure 2 shows that a circuit can be used to alter the brightness of a lamp. So we have a power pack or power supply, a lamp, and a variable resistor. The resistance of the variable resistor is increased. What effect would this have on the brightness of the lamp? So if we increase the resistance of the variable resistor, then the total resistance will increase, okay? So increasing the total resistance decreases the current. And if we decrease the current, the lamp will be dimmer. So therefore, the lamp will be dimmer. When the potential difference across the lamp is 3.3 volts, the current is 0.15 amps. Write down the equation that links current, potential difference, and resistance. So you could write down potential difference is equal to current times resistance. That's the easiest way to remember it. They would also accept resistance is equal to potential difference over current. They would also accept it in words or in symbols. So then the next part is calculate the resistance of the lamp. So usually, whenever you give an equation, you're then asked to use that equation to calculate the next part. So it tells us when the potential difference across the lamp is 3.3 volts, the current is 0.15. Calculate the resistance. Now I'm going to demonstrate this using this equation, V equals IR, because when I did the revision video, I suggested you learnt it in this form because it was easier to rearrange than this one. So I'm just going to demonstrate that. So if I've got V equals IR, I need to substitute in my values. So my potential difference is 3.3. The current is 0.15 times R. Okay, I want to get R by itself. At the moment I've got 0.15 times R, so I need to divide by 0.15. Whatever I do to that side, I need to do to this side. So I'm going to do 3.3 divided by 0.15, and that's going to give me R. And that will give me 22. So I've got 22 ohm resistance. Sketch a current potential difference graph for a filament lamp. Often you will get them like this. So if it's current potential difference, you'll get them on an axis where it shows positive and negative, and it would look like this. But sometimes they do just want you to give just the positive bit, so like in one direction basically. So always starts from the origin, because when the potential difference is 0, the current is going to be 0, and so your gradient is going to decrease like this. You need to be really careful that you don't start curving it back down towards the x-axis. So, but as the potential difference increases, the gradient decreases. So this is the higher paper only questions now. So a set of Christmas lights is made from 20 identical lamps connected in series. Each lamp is designed to take a current of 0.25 amps. The set plugs directly into the 230 volt mains electricity supply. Write down the equation that links current, potential difference and resistance. Well, we've just done this. V equals IR, R equals V over I. Same equation, just rearranged. Now, the reason that I still include questions like this when there is repetition is to prove to you how common it is for these sorts of questions to be asked. Okay, so calculate the resistance of one of the lamps. They put 1 in bold. Show clearly how you work out your final answer and give the unit. So to do this question, we need to think about what do we know about a series circuit. Well, so it's 20 identical lamps connected in series. Each lamp has got 0.25 amps, and there's 230 volts to the whole circuit. We know that in a series circuit that the potential difference is shared across each of the components. So the potential difference in each bulb is going to be the total potential difference divided by the number of bulbs. So 230 divided by 20, which gives us 11.5 volts across each bulb. Okay, so then we have our equation so that we can work out, because the current is going to be the same in each bulb because it's a series circuit, so there's one loop, one place for the current to flow. So we can do, again, let's just practice rearranging. So V equals IR, I've got 11.5 is equal to 0.25 times R. I'm going to divide this side, divide by 0.25, which means I have to do the same to this side, 11.5 over 0.25, which if, oops, 46, which I would write here 46 ohms because it's also asked me for the unit what is the total resistance for the set of lights. So the rule for resistance in a series circuit is it is the sum of the resistances. Okay, the total resistance is the sum of the resistances. So if I have 46 ohms each, and I've got 20 resistors, I've got 20 times 46 is going to be the total resistance. 20 times 46, whoops, 20 times 46 is 920 ohms resistance. So how does the resistance of a filament lamp change as the temperature of the filament changes? So we can say that as temperature, so resistance increases as temperature increases. They've given you quite a lot to write, space to write here, but it is only worth 1 mark, so all they're asking for is increase, decrease, or stay the same, really. If it was explain how the resistance of a filament lamp changes, then you might want to give more detail, or if it was worth 2 marks, that's usually your clue. Okay, so the diagram shows a 12-volt lighting system. Each lamp has a power of 32 watts. Write down the equation that links current, potential difference, and power. Power equals current times potential difference. Calculate the input current to the lighting system. Show clearly how you work out your answer. So again, we're going to look at we'll look at the diagram first. So first of all, 12-volt lighting system. These are connected in parallel to each other. So it's like its own kind of branch as it goes across. So each of these has got 12 volts across them, and each of them has a power of 32 watts. So we can work out the current in each branch, which would be doing P equals IV, and then rearranging. So we would do 32 is equal to I times 12, which would be 32 divided by 12 would give us the current in one of the branches. .6 recurring, so we're just going to leave that for a second, but that's in each of the branches. But there is 3 branches, and the total current into the system is going to be the sum of the current in each of the branches, so it's going to be basically that times 3. So the current in total is going to be 8.